Hello, welcome to Engine Room episode 4, where we talk about technologies that power American backbone of manufacturing. My name is Misa Ilkhechi. I am one of the co-founders at Formic, and today I have the pleasure of hosting two amazing guests. Jason Long, who has been in the injection molding automation space for the past 24 years, currently working at Wittmann as national sales manager. He has seen every bit of injection molding type of automation that could be seen. So would love to dig into his past experience. He's been in the industry for the past 24 years. And Kyle Kidwell, my colleague at Formic, and Kyle has 10 years of experience in the 10 to 15 years of experience in automation space, vision, robotics. Kyle at Formic leads our product management team, who's responsible for any injection molding and automation applications that we present to our customers. I'll pause there, but I'd love for Jason and Kyle to remind me if anything I've missed in their background, and I'd like to kind of tell us a little about their background and we'll go from there.
I think from my perspective, I think you covered it pretty well. So I wouldn't necessarily add anything to your commentary there, Misa. Jason, if there's anything you'd want to elaborate on as far as your background, I think you have a wealth of knowledge in this space. You've gone through the bumps and bruises and have a good level of experience here. So glad to just get your background.
Yeah, no, I think everything you said was right on. I've been doing this for almost 25 years now. My entire career has been 100% devoted to robots and automation in the injection molding industry. So when you said I've seen it all, I don't want to admit that, but I probably have seen it all. So
at least there shouldn't be any major gotchas at this point. So
yeah.
No, and I guess getting things kicking off here a little bit. One of the things that I think we wanted to get from your background is if you could give us an overview of the current state of the plastics and injection molding industry.
Yeah, for sure. Plastics is a very strong industry. It's the third largest manufacturing industry in the United States. Despite some of the things we hear in the news about how plastic is bad for us, it actually brings way more benefits to our economy and our health and everything. The injection molding side of that sector, or injection molding side of the plastic industry, it's pretty strong. The last couple of years has been record breaking for injection molders. Processors, molding places are very strong. This year, we've definitely seen a downturn in new equipment purchases. That's kind of backed with some uncertainty in the economy. Some things like the big projects have already been in works, and they're trying to work through installing all those they bought over the last year. But even with this downturn, it's still a huge market. The automation side of that is even bigger. So there might be less injection molding machines being purchased right now, but there's just as much automation and robotics being purchased in the industry.
Yeah.
Okay.
To piggyback off that, what has been the impact post-pandemic for the injection molding and plastic manufacturing in general, with all the supply chain issues for some companies that might be importing things? Are you seeing an increase in volume of production here in the U.S.?
We are. We definitely seeing more what we call onshoring, so bringing things back from China. A lot of that's coming to America. A lot of that's also still coming to Mexico. So it's a North America onshoring. We're also seeing globally, even companies are pulling out of China or looking for other manufacturers. Some of them are still staying in the Asian market. So Vietnam, Singapore, some of those areas are benefiting. The United States, the pandemic, the supply chain issues really, I guess, taught us a lesson of how we need to be a little more diverse in what we do in the industry. And especially when it comes to medical things, having boats off the shore with all the medical supplies you need is very hard when they're sitting out there. So a lot of medical, a lot of automotive side also is being brought back to our shores.
Amazing. Glad to hear.
One of the points you made a little while ago was that a lot of big projects have already been in motion and that companies are working to get that stuff installed. Where would you say you've seen the most growth in injection molding over the last 2 or 3 years?
We break injection molding down in sectors. Medical is always a strong sector, and that's probably we've seen the biggest growth. Medical devices, medical medicine dispensaries, a lot of the one-shot dispensers for if you're taking a medicine. The old way of doing insulin where you had to measure it out in a syringe. All that's being done in single-use, one-shot systems. This year, we've also seen a reinsurgence of automotive. So during COVID, automotive really slowed down. Supply chain issues, chip shortages, all that stuff we heard repeatedly over the last couple of years. That's picking back up. Supply chains not back to normal, but getting pretty close to back to normal. So we're starting to see new car models and production pick back up in the automotive sector.
Okay. With some of the one-shot production or one-shot manufacturing or implementation of the medical devices, has there been a peak of recycled material, or how much of it is new material that's getting used in plastic space?
So in medical, a lot of it is what we call virgin new material, due to quality issues, sanitaries. But recycling is always big in the plastic industry. When you look at automotive, if you look at plastic bottles, cups, consumer products, recycling has always been big, and we're definitely seeing a huge improvement on how we do that. Sustainability is always a big topic in the plastics industry. How do we reuse it, and how do we stop throwing away certain things? But again, like the medical side, it's fairly new. It's very rare you see a lot of regrind or reuse material. But that's, even though it's a big sector of plastics, it's still not one of the biggest sectors. So a lot of the plastics you see being sustainability and recycled, automotive, consumer products, that's still very huge and will impact our industry for a couple more years or longer.
Okay. No, that's great. That's great. It's I think talking through recycling, regrinding versus virgin material that's used, that's stuff those are terms that are widely known in this area. With injection molding, the processes, the dependability, or like the cadence of how the molds have to open, the amount of material that they have to feed, the temperature. There's a lot of different factors that go into successful manufacturing of the different products. When it comes to implementing automation around that, what are some of the factors that a manufacturer needs to be cognizant of?
So there's a lot of factors for injection molding when you look at automation. Obviously, the big driver for automation in plastics or any industries is labor. So we always have to factor in you're adding automation to take away labor, but something to keep in mind is you still need that support structure to support that automation. So there's still a need for high skilled labor to be able to support that end use of the product and how you maintain that automation over time.
Sure.
A lot of the factors when looking to automate, labor shortage is one of the biggest one. Companies are looking for consistent cycles. It's all about cycle time and injection molding. How fast can you make a part? How many you can make in an hour or a day? You look at quality. So when you're looking at the return on investment and how you can justify automation, you're looking at a bunch of different areas: labor, quality, consistency, safety is always a big factor. Just all that needs to be calculated into, not just this piece of equipment costs this much. What is it doing, and how is that going to improve your efficiency?
Yeah. No, and I know you talk about safety, and that's always a concern that we look at and we dive into a lot as we deal with applications all across the ecosystem that we look at from Formic. I know, in the injection molding space, you have a bunch of standards that get applied. I know that historically there's been iterations on the Euromap standards. A lot of the older machines are running on Euromap 12, also known as the SPI interface, whereas now it's very common to see Euromap 67. Would you be able to expand on what the benefits or why those standards are in place, and what some of the benefits are for people that are looking to deploy automation in this space?
Yeah, there's a lot of safety standards. The injection mold industry is very, I don't know how you say it. They're old in their technology. If you go to a molding shop, you see a lot of old machines. We expect machines to run 30 some years. So, 20 years ago, you had a lot of different standards on how to hook automation, how to plug a robot into a molding machine or something. The Euromap standards come out to help try to pinpoint that down, so manufacturers and users have an understanding what it needs to be. Like Euromap 12, and you have the newer 67. I call it new, but it's been around a pretty long time. Even now, the new Euromap OPC UA standards that are going to be introduced for those kind of interfaces. And those interfaces, it's all around the safety. Euromap 12, they had safety systems, but they weren't redundant. The Euromap 67 has that redundant safety system. The OPC standards will still have all that safety redundancy, but they're looking to tie in more technology to grab more information from machines. And the Internet of Things that are you hear out there, they call it 4.0 or the industry 4.0. The safety standards, it was a long time, especially with robots that's normally the gantry style robots like Wittmann makes. That's normally tied with molding. It's a sector, right? We make molding machines just for injection molding, unlike a 6-axis robot that kind of more universal you see out there. So it took a long time for the industry to be able to adapt the safety standards from normal industry and bring them into the molding machine. So you have the ANSI and RIA standards that OSHA and everyone's adapted to bring in. It's all how you take what we've already known throughout all different industries and bringing them into how to adapt that to a molding machine cell.
Sure. And
so,
go ahead, Misa.
Yeah, just to piggyback on that. So from my understanding, Wittmann is an Austrian company, European company, and oftentimes what we see in the world of automation, Europe is kind of leading the way in defining standards, adopting automation and robotics. What do you think is kind of the main differentiator for us to lagging behind in Europe and in general the rest of the world when you look at the total number of automation piece of equipment that goes in? What do you think is kind of the deciding factor of why we are slightly behind in developing standards and adopting automation in general?
I think a lot of the standards being wrote are they're adopted or started being adopted by manufacturers. The United States doesn't have really a lot of injection molding manufacturers. There's basically one or two companies that actually manufacture or are U.S. based. So a lot of the key players for injection molding, for instance, is in Europe or the Asian market. Europe is definitely more automated than a lot of the world, and they've been ahead of that curve for a while. The United States, we've kind of been driven to get more automated, to be more cost effective and efficient compared to the rest of the world. But the real driving factor you see that Europe is even things like government mandates and stuff like that. It's a lot more prevalent in Europe than here. In the United States, we kind of tend to slow roll into these kind of safety mandates. Not saying we're not safe, but the mandates that tie to them. But the real driving force for Europe is that's where a lot of the manufacturers for high-end technology is, especially in the injection molding world.
Mm-hmm.
Germany and Austria, these are big spaces for big injection molding manufacturers.
No, makes sense.
I would say that makes sense. I mean, if you look at a lot of the other companies that are in the 6-axis world of robots, they drive a lot of the safety standards that you see from ISO that trickles down through ANSI and RIA and A3 and everything like that. And yeah, those companies are based in Japan, they're based in Germany, they're based in Northern Europe. It's all throughout the world, and I would say that definitely resonates. So when putting together like a justification, I know we like from Formic, we take a look at a lot of systems and we're trying to put together justifications for customers and help them basically tell a good story or pitch this up the chain to the decision makers of their companies. What are some of the key factors that that most manufacturers you've seen have used for justifying whether it's deploying automation around injection molding or purchasing a new injection molding machine? Kind of how do they run that calculation on a high level?
Okay. I mean, like injection molding, really you have custom molders and you have molders that mold their own product and everything. Looking for molding machines is all about capacity, really. If a molder has a setup with 4 or 5 machines and those machines are at 80% capacity, they're looking to add more because that's the golden rule. If your machine's running 80%, if you think about downtime and productivity, you start to look for, I need more molding machines. I need more capacity. If you're a custom molder, more molding machine means more molding machine time you can sell. So that's another driving force. With robots and automation, there's a lot of factors when people are trying to justify those robots and automation. The biggest thing I said earlier about labor, that's always going to be a big factor. It's not that people need to replace labor, they just can't get labor. So the automation needs to be deployed. And here in the United States, we need to employ automation to be competitive against the rest of the world to do that. The other thing, again, with automation, it's a lot of consistency. If you have people tending molding machines, taking the part out of the mold, they have to open the door, take the part out. That can be done in 30 seconds. If the operator's a little slower at night, it can be done in 45 seconds. One of the biggest drivers for the ROI is the consistency a robot and automation brings to your cycle. The other thing about safety, entering a molded machines with your hand is safe. The machines are designed that way. But if you're inserting metal pieces into the mold for over molding, there's chances of someone getting cut. The parts are hot. Injection molding is all about melting plastic and cooling it back off. So some of these parts, we just had a customer yesterday with a 350 degree part. You can't grab that part. You don't want someone grabbing that part. And then, it's then quality. One thing justifying looking at quality systems is like, how can I make a quality part? Plus, how can I have the robot or the automation check my quality instead of having to have someone sit there and look at every part. And over time, that person might miss something, some little mark or something like that as they're checking 100 parts an hour. So it's bringing that robot and automation in to have that visual check. They're usually a lot more accurate and a lot faster at checking quality.
One of the trends that we see when we talk to our customers and previously before Formic, I think one of the challenges a lot of manufacturers that we see face is the visibility into future, right? So they don't really know, they don't have per se long-term contracts with their end users, right? Whether they're making components for appliances, automotive, they don't have the visibility into the future. So it makes it very difficult to justify the expenditure of the automation. When you're presented with this kind of challenge, when customer provides you, says, hey, look, I don't know, I've been making this part for the past 20 years, but I don't know how much longer I'm going to be making it. So what do you typically respond to that?
So I guess with robots, it's a little easier because you can say you're not going to be running that product in that molding machine forever, but you're going to have that molding machine and that robot running. So the robots can be quickly adapted to run other projects for you. When it comes to automation, usually the return on investment, when you said you're uncertain where that's going to go, a lot of times, like in the medical field, the person making the part, the medical company buying the part, they actually end up buying the automation to help justify that, and they can move it around. But when it comes to the automation, if you're looking at custom automation, it is kind of difficult to justify. But you just have to look on what that automation system's doing for you. How much uptime are you going to have? How faster can it run? What's the better quality? And even if you're going to run that product for 2 or 3 years and you don't know what's happening after that, you're going to get your money back. In injection molding, the automation robots we make, most of our customers see a return on investment within, if it's a robot, it could be a year. I mean, medical, sometimes even less than that. Automotive, it might be another 2 years, but most cases in automotive, you're going to be running that part for a while. That mold's going to be running for a while. Even if the car's out of production, you're still running support, service equipment and service parts for it.
Yeah, sure. Let's dig into that a little bit. I'd love to kind of maybe for somebody who doesn't understand anything about automation of injection molding, when you're looking at automating it, there's option to deploy a gantry or sprue picker. Like, can you give us an overview of the technologies available and how flexible they are in terms of adaptability to run new parts for their machines?
Yeah. So one thing unique about the robots you normally see in injection molding, when it comes to the gantry style, most companies design them for molding machines, and they're not designed for a specific application. So when you do have sprue pickers, which are designed just to pick the runner or not really the part, those still big in the industry. But most of the time when we see new robots or new automation being deployed, it's servo robots, gantry style. They have options, right? So you set up them with enough vacuums and gripper circuits to be able to run not what you're doing today, but enough for in the future. So when we talk to customers, we're specifying what you're looking for. We size the robot strokes for the machine. We figure out what are they doing right now, how many vacs and grips, how many I/O do they need, and then we always say, all right, what do you think you're going to need in the future? And if they're saying, oh, I'm going to buy this robot to pick this part, just place it on the conveyor, but I want to do automation in the future. So the robots are very adaptable to be able to add those options when you purchase it, but also later. So Wittmann spends a lot of time in our parts departments retrofitting robots. So if a customer says, I bought this robot with 8 I/O, but now I need 16, these are standard options for our robots. So they're easy to call our department, buy a standard option, put it into the robot, and start up and get ready to go with the new options you need.
Interesting.
Yeah, I was definitely impressed to see how modular and how adaptable the circuitry was on the robots. It's basically a plug and play option to expand or remove parts.
How about tooling? Because I think one of the other things that it becomes a cost center for injection molding, automation, gantry style systems. What is that? Is there a rule of thumb on how much you should be spending on tooling compared to the robot that you're buying, or it really depends on the part?
It really depends on the part. Yeah, you're absolutely correct. I can tell you, I've sold in-one tools that are probably more money than the actual robot was. What we're doing with it. There's always especially in our industry, there's always different avenues for what the customer is looking for. Something that Wittmann does in house is a little more custom and specific for a job, but there's companies out there that specialize in selling just components to build in-one tools. So it's a very cost efficient way for someone to look at, I need to grab this part. It's like a rector set. How do I build this? But if you're looking at doing insert molding or more complex things, the in-one tools can get pretty expensive, pretty heavy, pretty big, based on the application. But what I've really enjoyed in my career, because I've worked for an in-one tool company before I came to Wittmann, so I've seen both sides of. There's definitely companies, people, and ways that you'd be very cost efficient in getting your automation implemented. In-one tools is a place you can save a lot of money, or you can spend a lot of money. Depends on how automated you want to be and how robust you need it.
So I think the moral of the story is then the gantry systems are fairly adaptable. Always try to get something that's a little bit maybe oversized, more IOs than you need today. So when you run something else in the future, you could kind of automatically, without having to go back to you guys, have those capabilities already built in, so you could retrofit it and run it. And is this something that customers could do on their own, or every time they're trying to kind of retrofit something, they have to bring it to Wittmann, so you guys would do the modification?
There's definitely things they can do on their own. If they're looking to add the options to the robot, usually it requires some kind of software update that most manufacturers like Wittmann kind of take control of. It's our software, it's to our robot. But there's a lot of customers out there. It's like, I need an extra gripper circuit for an in-one tool. They could buy a valve and put on an in-one tool and just use IO in the robot. But you got up a good point about the flexibility of the robots. And one of the biggest things we see in our industry when it's sizing gantry robots is, the bigger the robot, really how much more money it is. It's correlation of size right there. And we see a lot of companies go from smaller robots that may be designed for a smaller tonnage machine, but they like the price and it kind of fits their application right now. But a lot, I don't know, I want to say 40% of the time, we end up hearing that, hey, this robot does not have enough strokes than what we needed. It worked 5 years ago. It's just not working now. So really paying attention to how to not oversize, but to be able to size that robot for your future use.
Yeah, makes sense. So, on that note, I've seen the input intake form that you have to size up the machines. Very impressive. I think Kyle showed me at some point. I think it's one of the most complete intake forms I've ever seen, and I'm sure that has come from experience and kind of learning that you've had. It wasn't something that it was conceived in an hour. So, but for a lot of people who are not familiar with automation, for a lot of people who don't have automation today on their floor, what do you think is the best way to educate themselves and understand, so they could put the right scope in front of somebody, right? To develop an understanding of scope and creating, what they need. What kind of resources would you recommend them kind of looking into and researching?
So I guess when it comes to robots, it's learn from other people's experience. I've always teased plastics industry is a very big industry, but it's ran by the same 5 people. They just move from company to company and take their experience with them. So, if you're getting new in automation, finding an integrator that has done this kind of automation. There's a lot of integrators out there. You guys work with a lot of them, right? There's a handful out there that's really dedicated to plastics and what it takes to do this industry. Just learning from them and getting an understanding. When you're first starting out, I always suggest looking for an integrator, someone like Wittmann or other integrators that can help you walk you through your first project and what to look for and really learn. That sizing sheet you said is pretty detailed. It's something we give to our customers. even our sales guys always push back. It's like, do you need that information? And it's usually the one project we say, all right, you didn't give that information and now we need it. It's important kind of a thing.
Makes sense.
That sizing tool goes over a lot of measurements that a lot of people don't think about when they're looking at how close your ceiling is to your robot top of your molding machine, or, I can reach center line of my mold with my robot, but you might have application we got to reach past center. So it's if you're just getting automation, it's really learning from people and getting a hold of somebody. And we have a lot of customers that we might do a big automation project. And then they quickly turn around and realize, I can just buy the robot and start doing my own automation and have a little bit more control. There's definitely benefits to doing your own automation. You learn a lot doing your own automation. You know the ins and out of that piece of equipment like no one else when you're building it yourself. But there's still plenty of projects that they look for integrators, and just learning from each one of those projects.
Makes sense. Yeah, I mean, that's exactly the reason we've kind of did Formic the way we have done it. We work with machine builders and integrators that are very experienced on what they do. And matter of fact, we work with you guys. You have some of your systems running in a couple of our customers' facilities and looking to expand on it. But when you're looking to kind of figure out who the right integrator is, what kind of questions would you ask if you're the customer to find out if they are a good fit, a good partner to work with?
Well, when it comes to plastics, I would 100% ask if they've done injection molding automation.
That's fair.
It's a lot of. I'm a sales guy. I've not always been a sales guy, but a lot of sales guys think they can sell anything. A lot of integrators think they can do anything. But if you look for someone who has that experience, the other thing is you're looking at support. The engineering support. How much time do they put up front before you even buy the product to help you understand what you're buying? How much time do they devote into the actual engineering? When you look at how much time they give you to look over their product and make suggestions. So when you do automation projects, you always have a design review. We present it to the customer. We want their feedback, kind of a thing. How open is the integrator to that feedback and learning from what you know as a molder? And then support. A lot of automation houses, a lot of what people do, they look for integrators that are local. And that's key because you want someone to be able to help support you in the field when you need it without having to fly someone across the country. But even if they say they have that support, what is that support level? How many people do they have working for them? Do they have service people? All of them have engineers, controls, and mechanicals. But those are the same guys building the next project they have in place. Do they have a team that's able to support the in the field stuff you already have in place? And it's not really the size, really. It's just their support network. Because I've worked with integrators with 3 or 4 people and can support customers better than a company with 100 employees. But it's really important to understand how they go to market with their service and support.
Interesting. Makes sense.
And their product standing behind what they're actually going to be putting on a customer's floor.
Yeah.
And I know, tangible customer feedback. I was at a customer last week with one of our systems, and it's running overall. They're fairly happy, it seemed, but I'm talking with the plant manager, and there's a couple things that he was pointing out that would be like feature improvements or requests, and he's like, I wish he made that statement of, I wish I was actually a little bit more involved up front on some of the engineering phases of stuff. And I'm like, that's really good feedback. That's
the reason I went into sales. I was a service tech for many years. So I was the one out there installing it and running it. And I really thought about it. I want to be on the front end. So the stuff I'm out there fixing, not always bad, but I'm out there fixing. It's like, I want to be the one up front to help them pick and spec and design these systems before they get to the service side. And as a service tech, you're always out there. Why do we do it this way? Like you could be the upfront guy and help understand why you should do something a certain way and to help support it.
Absolutely. So you mentioned support, and I could not agree with you more, right? There's a lot of people, but asking specifically what system you're getting, do they have experience, and what's their service structure looks like, it's absolutely key. I agree 100%. Digging into servicing these types of machinery, what are typically things that our customers are responsible for? What are things that are a builder or the system integrator, the OEM like yourself is responsible for when it comes to service and maintenance?
So in our industry, let's say in the robots per se, once that robot's installed, we warranty it. But the customers are responsible for the PMs, and they normally, in plastic injection molding, there's not a lot of PM contracts. They're not really outsourcing the preventive maintenance side of things. That's something they do internally. Programming, we really stress training. So we want our end users to be able to program and make adjustments to teach programs when they need it. And especially for custom molders when you're going to be running different molds all the time. So it's programming should be one of those things that are 100% the customer needs to take some responsibility. Finding the right manufacturer that has the support to teach them, having the right equipment that can be learned. So in the robot industry, there's 30, 40 robot companies out there. Every single one of them are programmed differently. Every single one of them have a different controller. Unlike like injection molding machines, there's 30, 40 manufacturers there, and they all have their own software for injection molding, but you can kind of get the same gist. They know where certain things are. You just got to find a screen. But in robot and automation, whether you use a PLC, you got to learn ladder logic. Whether you program like a Wittmann robot with conversational language, there's some robots that use ladder logic or flow diagrams. You want to be able to be able to use that. The service side, like what we normally have, we do have service techs, and most robot companies in automation, for the plastic industry, have a whole nation map of service techs. It's one of the first slides we show in our presentations. It's one of the first questions customers ask is, what is your support network? Most customers, most injection molders have great maintenance teams. They can maintain a lot of stuff, but when they can't, they want you to be able to support it pretty fast. So, a lot of support from us come from phone support or web service. That's something a customer almost all requiring today. How can we remote into their equipment to be able to troubleshoot it and help pinpoint it? That's an easy thing for the customer to be able to network, and then our quality experts can go in there and help them walk through what needs done. They're still really making the repair. We're just helping them walk through what needs done.
It's nice to be able to track where in the process they're having the issues, be able to kind of have the eyes, and that is definitely one of the things we're doing with Formic, but also, like you said, is an industry trend of the industry 4.0 of being able to sit at our computers here and you can look at a system in California and Washington and Texas, wherever the systems are. We can actually be providing the support without having to have somebody on site. And that is impactful for a lot of manufacturers, a lot of customers, because while they're not necessarily the expert in your system, they can do a fair amount of the work if they have a little bit of coaching.
Yeah. Remote service, injection molding. Let's say an injection molding machine. I would say our team over there behind my office here are on remote services a lot. 80% of the calls we get in a day can be actually solved by remote service. Robots and automation, it's a little bit more tricky, but it's still the same. A lot of times being able to remote in. The OPC standards are really changing how that happens and what we do with it. The biggest challenge for remote service is IT networks and what customers really allow us to access to. So companies like Wittmann are pioneering ways to do remote service without having to get into the customer's network. The old way of plugging your robot into your network and allow someone from the outside to enter that network. Now they have their own self-standing networks to be able to do that with cell plans or whatever that needs to be to happen. Once that technology, again, I said earlier in this time, with injection molding is always behind the curve with kind of technology. That technology has been out there for a long time for everything from a toaster to a microwave. But when injection molding, remote service has been something that's really started being more prevalent in the last couple of years, 5 or 6 years, with access and allow them to do it.
Absolutely. I think you mentioned something. I think having one way of doing LTE chips and connect with system is really. I think it's on the rise. We run into similar issues. Every system we deploy has an edge device that monitors robot usage, and we can kind of look at any anomalies that are happening in the machine so we could troubleshoot and service them. But sometimes the larger the customer, typically tapping to a network becomes more difficult. So I'm glad to hear you guys are finding alternative ways to provide that great service without going through the hassle of figuring out what IT standards that specific customer has.
Yeah.
I think another area that you mentioned is customer taking ownership of the system and being able to do very basic things. And I'm sure this is not foreign to you that there is a lot of turnover at a lot of manufacturing facilities. So somebody might get trained on how to use the product, and then now they're not there anymore. What is Wittmann's training structure looks like? Do you have remote training? Do you have online training, in-person training? When somebody buys a piece of equipment from you, specifically whether it's the robot or injection mold, the press itself, what is your training infrastructure look like?
So it's all of the above. Every piece of equipment Wittmann sells normally comes with days of training. How many days depends on if the customer is used to our equipment already or if they're new. So we do the startup and we do some basic on-site training. We have a training network. So Wittmann has 3 or 4 locations throughout the country. Our personal tech centers, the ones we've owned, we do training classes. A basic robot training could be a 3-day course. A maintenance training could be a 2-day course. The customer has to leave their factory and go to a facility. That's tough nowadays to get people to leave facilities, but we still stress how important it is to get the person we're training out of their work environment. Because a lot of times we do on-site training, the guy's sitting there listening to us talk, but then there's the guy next to him pulling him saying, hey, I need help over here. Can you just take 5 minutes to help me? Or can you take 5 minutes? Those 5 minutes add up fast. They're pulled away from our training classes quite a bit. We also do a lot of web-based training. So, we have webinars that can help do a lot of the more easier stuff or maybe pinpoint topics that the customer is looking for. It's hard to keep someone focused on a 4-day training program for training programming robots when it's this kind of atmosphere. We're just talking to a microphone, but it does help out there. We've also focused a lot on the YouTube videos. In today's world, when we want to fix anything, we look on Google and say, how do I change my tire or how do I change my ball bearing on a car? The industry is moving that way with automation and robots. So you go and say, how do I program a vacuum circuit on a Wittmann robot, and pops up a YouTube video, and it's short 3 minutes and the customer gets it. That's mainly what those guys are looking for. How do I fix the issue I'm having now? So the combination of on-site training during startup, the facility training at any one of our locations, followed up by maybe a webinar. We do training for 3 days. They might go back to their factory and forget 6 months from now what a certain thing was. They can have a quick refresher webinar just on that one topic. So whatever the customers need, we try to focus on providing it for them.
I agree. Yeah, makes sense.
The video goes a long way. It saves a lot of resources, a lot of time and effort, and it's hugely beneficial. So if you had to guess, or best guess from your position, how many injection molding machines would you think are running in North America?
That's a good question. We were actually debating this morning with my colleagues.
Perfect timing.
Out there, injection molding, there's 3,000 to 4,000 new injection molding machines being sold every year in North America.
Okay.
There's over 11,000 molders out there. Some of them have hundreds of machines. Some of them have 5 machines. Our best estimate, I think, talking to everybody, we'd say it's probably about over 250,000 injection molding machines in North America producing parts today. When we say there's 3,000 to 4,000 a year being purchased, that's some new projects, some replacement projects. I mentioned earlier, injection molding, people hold on to their molding machines a long time.
Sure.
I was at a customer, it's a high-end sports company that's been making their product on the same machines for 45 years, and they're just now investing in new machines. So it's, you see that, it's like, wow, those machines, great, they lasted 45 years. That's kind of unknown in world technology today. But based, 11,000 molders. Some of these are the biggest molders in the world. So there's a lot of molding machines out there.
Yeah, most of these machines can run forever. I've seen 40, 50-year-old presses that are still running just fine, no issues.
Across manufacturing, you look at a lot of mills, lathes, press brakes, all these different types of equipment. Manufacturers love to keep the old equipment because it maintains the tolerance. It was built extremely rigid compared to the stuff now. I guess in injection molding, like with newer molding machines, there's a lot of technology as far as circuitry and advancement in, controlling them. Has there been any increase or decrease in like the actual quality of the machines that are getting produced today?
No, I think with anything in the world, you'd say something built 40 years ago is probably built more robust. Obviously, the way technology is and how fast you have to produce things, I don't think quality goes away, but life expectancy starts to go away sometimes. Sure. There's some manufacturing injection molding machines that make the same robot they did 20 years ago. The real thing to look at when like injection molding and even robots for injection molding is you can run those machines for 30 years, but if you don't look at new technology, you're going to be losing out a lot of stuff. So a machine 20 years ago, it's not as fast as a machine today. It doesn't have all the same quality processing parameters control you have today. It's not going to give you that remote service you have today. And then their obsolescence, right? It could still be running for 40 years, but we have customers we've made robots for over 30, 35 years now. Yeah, a long time. There's still people out there running one of our 2 series robots, but trying to find that servo drive from 35 years ago would be almost impossible today. But in the same hand, that robot is nowhere near as efficient as today's design. So
yeah.
Well, I think what just to follow up on that, I agree that the machine's built in the best; they're still running, but just having downtime of not being able to find a part to get the machine up and running, sometimes we'll just might as well just go buy a new machine. But I think manufacturers sometimes like really can't get over this hump of look, just if this machine goes down for 3 days, all the money I was going to spend, on just getting rid of this and getting a new machine would have been paid off. But what do you typically tell customers when they are kind of fighting that battle of buying a new machine versus kind of keeping the old one? Is there a checklist of items that you ask them to go through? Is there a study that you provide them to kind of help make that decision-making process a little bit easier?
Yeah. So one of the first things we do in injection molding robots is we do cycle time studies. How much faster is a new robot today? Because again, in molding, it's all about cycle time.
Yeah.
And how much time that robot spends in your mold, that's taking away molding time that you could be doing. The next thing is obsolescence. You're talking parts wise. Yeah, if you're down for 3 or 4 weeks waiting a part, really do a time study on what your robots or your mold machines are doing. How much time is down? If most of these customers that are holding all these machines, they're not really tracking how much downtime this equipment's having. And if you really sit down and try to help them figure that out, and you realize, you're supposed to be getting 95% uptime, and you're only getting 65 or some 35% uptime, you really start that piece of equipment. Yeah, it's going to cost you a lot. A mold machine, let's say, it's $100,000 to buy a smaller mold machine, but you're only running 35% of your capacity, your uptime in your current system. That's a huge fast ROI. In robot worlds, that's where you really get to the ROIs of 6-7 months time. If you have a robot that's only up 70% of the time, replacing a $50,000 robot, that can be justified really fast.
Sure.
Absolutely. I agree.
On this whole topic of older equipment, newer equipment, everything like this, when you're saying about 3,000, 4,000 injection molding machines are getting sold every year into North America. Out of each of those machines, what would you say the percentage of them go out with a new robot attached or included?
So today it's probably upwards of 60% of every new mold machine has a robot. If you would ask me that 15 years ago, it would have been less than half. But that mentality's changed now. It used to be, do I need a robot? It's now, can I need a robot? It's not a question. I have to have it. So majority of the robots out there, for instance, we can see that if 3,000 to 4,000 mold machines being sold a year, there's 2,500 robots being sold a year. And majority of those, the way we track that is based on new robots. Some of it is replacement and stuff like that. But it's, if we look at our mold machines we sell, it's 50, at least 50%, almost 60% of the time it has a robot attached to it.
Okay.
I'm assuming, I know that you do actual retrofit of old machines that are already existing in the field. What are maybe a few factors that will prohibit you from automating a press? It might be an old. Are there any specific hurdles that exist with some old machines that can or can't be automated?
There are. There's not a lot of them. The biggest factor is the robot interface, how that robot handshakes with the mold machine. If there's some mold machines out there that just don't have the options to add a Euromap 12 or Euromap 67 interface to it. There's ways around that. Some customers have adapted their own way of doing it, but that's one of the biggest things. The other, really, there's not the technology, the actual hardware, how a hydraulic machine works hasn't really changed. It's really around the how you handshake with it. Some of the old ones, we don't see a lot of them anymore. Even if they had a robot interface, it's it was a very scaled down version, so it might not have the redundant e-stop circuits or safety gate systems. So they, if a user put their own interface on it, it might not be a complete interface to the standard. Besides that, that's really the only thing would stop you from saying, I can't put a robot on this piece of equipment because it's so old. People actually do buy brand new robots to put on 30-year-old machines, and we do it all the time. So
amazing.
That's awesome. The last thing I was going to ask you, and I think this was one of those, the tour you gave me of your facility up in Torrington, great show and tell. I'd recommend that anybody who's looking at it, talk with the group of Wittmann, see what you can do to get a meeting set up where you can actually visit one of their facilities across the country. They do a ton of different applications. They have a lot of good samples. What's one of the most unique applications you've had to, work through deploying for automation?
The ones you can share, because I'm sure there's a ton that you
can't. Things I can't really share. So for me, we've done some things in the like the ammunition business that's pretty unique. I can't go too much into it, but that's a weird thing of looking at, is saying, oh, there's plastics and ammunition. We've some unique challenges. Normally it's the simple things you don't think about. A couple of years ago, we had a project for a customer that makes hanging flower pots, and the hook that the flower pot hangs on, they make that system. We had to pick those off and put them into a bag and put them in a box, and something that I thought, it looked pretty easy. I hate to use that word, but that's what I would say it was. That was unique because it was like playing a game, the Barrel Monkeys game, where you pull one out of the container and they all come with it. That was always a fun system. But in injection molding, because plastics is in everything, one thing I enjoy about my job is in 1 week, I could be talking about a plastic bullet of some kind, all the way to, a yogurt package, all the way up to car parts. It's so diverse in what we look at. And like you said, when you come to Wittmann, we have that show and tell. You see all the parts from medical and automotive, the board game systems that are still being made in the United States. It's fun to see everything. Because I said earlier when we started, plastics kind of gets a bad rap when it comes to water bottles and straws, right? But the benefits of medical devices I've seen over the last 25 years it's incredible. The technology has been driven in benefits. Cars, the amount of plastic in a car sounds bad, but it's sustainability. You have to get the cars lighter so they don't use as much gas or battery power. And plastics is often safer when it comes to certain things. You don't want metal crumping up against someone. You'd rather have that plastic part be there. So unique wise, we've done a lot of unique systems. Not all I can share, but there's been a lot.
That's awesome to hear. Jason, one of the things that we'd love to do as a part of this podcast and information session, if you will, we'd love to kind of get people's thoughts that have been in the manufacturing industry for a very long time on how do we attract more people to come into the industry, right? There's a lot of talent that is going to retire, technical talent is going to retire, and there's just not an influx of enough people that want to come into the world of automation and manufacturing. First, I would love to kind of hear your thoughts on why do you think that is, and what we could do as an industry to bring more and more people and into the industry.
My opinion on the reason why we've kind of made manufacturing automation not as cool anymore. It's kind of mainstream. It's just something that happens in our industries. I actually interviewed a kid a couple months ago. Came out of college for robotics, and we interviewed him here, and he decided, he didn't want to get into plastic robotics. It was kind of boring for him. He wanted to go do something more in the aerospace. And, I told him, you'll probably eventually learn it's all the same thing. It's just different sectors. I've always pushed to get younger people into manufacturing. Is we have to start them early in high school and technical schools and stuff. Get them to understand that, it's important to get your college degree. It is. You need your college degree. But if you introduce them to that kind of technology in technical schools and understand that manufacturing not always are degrees. Most of the best maintenance people I've seen out there have no degree whatsoever. But they could walk circles around anyone with an engineering degree. But it also, manufacturing sector needs to adopt that, right? They need to go after those kind of things, help support those type of people. One thing Wittmann's done in the past, we have like our Wittmann Academy, where we actually go look for high school, first year college students, bringing them into our program. And it used to be called an apprenticeship, was kind of a thing. But the way the academy works, they get brought on for 6 months to a year, going through all our different divisions that we have here, from robots and injection molding to auxiliary equipment. They spend time in engineering, they spend time in manufacturing, they spend time with our sales guys to learn all aspects of it and kind of get them interested. So when they start to go to college and start looking at what they want to do, they have an understanding of what the real world is. One thing I could say Europe or the European or does very good is apprenticeship programs. In the United States, we've kind of got rid of that. We don't go after those young guys and help them be educated and assist manufacturing, help pay for their schooling, and getting rid of that kind of apprenticeship. You see it in some aspects. In injection molding, you hardly see it anywhere. Maybe the mold maker themselves, the people that make some molds, they have apprenticeship programs, but in manufacturing, there's not much of that anymore. We strive to be engineers, but we don't strive to understand what it takes to get to that point. And
sure,
I agree. I love that quote that you said. Manufacturing just happens. That's definitely the impression that people have that are not in the industry. They think it just happens. Stuff that shows up in the grocery store, the car you drive,
all the
everything
Amazon deliveries,
fairy dust, magic just happens.
Yeah, it's somewhat like they think it's when they look at how a Lego's made, like they don't realize how much engineering goes into that, and they think it's just there. And then the other aspects is the ground floor. When young kids want to get in industries, they think they need to jump 4 or 5 rungs to the ladder to get in there. So when they go see, to get into this industry, I need to start at a lower rung. Well, that's boring to them. But that's where a lot of us took the hard knocks and learned it and moved up. So,
awesome.
Manufacturing. It's fun to see. People like to watch those shows of how it's made. We get to see it every day. It's a reoccurring show for us to see what things are made. And
I agree. Me and Kyle, we've been working together for a very long time. Fortunate enough to walk all sorts of manufacturing facilities, from large automotive to small, medium-sized companies in heartland of the U.S. So yeah, definitely fun to go and walk these places, hear the stories, understand how they get started. So it's definitely been fulfilling for me, and I'm sure Kyle as well. So I could not agree more.
And writing on that a little bit, one of the eye-opening things that I've had throughout my career, which I don't think a lot of people realize, again, manufacturing just happens. A lot of people look at it and they view everything coming from China, coming from, Southeast Asia. I don't think many people realize how much stuff is truly made in the U.S. I think that's really overlooked and overshadowed, because there's a lot of stuff that you use every day that it's maybe getting made within an hour wherever you're living.
Yeah, exactly. Absolutely. I've been surprised personally to walk factories and understand, hey, I did not know this is manufactured here. That's
there's a lot of stuff. Yeah, almost. I mean, there's some things not made in the United States anymore, but for the most part, there's probably some manufacturer making some version of that product here.
100%.
Some companies are driven. When you have the larger big box retailers drive for that, you really start to see it. I'm a plastics nerd. If I go into a store, the first thing I look at in plastic is the label, where it's made at, see who's making it and where it is. We always say there's a lot of made in China stickers. There's a lot of made in USA stickers. It's not always the cool stuff you want to pick up and look at, but if you really pay attention, there is still a lot of made in USA stuff. And luckily, what we're seeing, a lot of it's being brought back too. So.
Yeah, I could not agree more, Jason. I feel like there is, if he can figure out the automation piece, if he can really get rid of all those mundane tasks that we have to do, reduce our costs, reduce cost per part through robotics and automation, we really get to manufacture a lot more, because at the end of the day, raw material costs the same, machines cost the same all across the world. So if we can kind of really crack the code when it comes to automation and robotics, there is a lot more we could manufacturing here.
I've always said that's key for U.S. to be competitive is automation. You're not going to be competitive with cost of living. It's more here than it is in other countries.
100%.
Automation was what drives you, the user, to be more competitive.
100%. Awesome. Jason, I really appreciate your time. That's the extent of question I had. Kyle, did you have any final thoughts, questions?
No, I really appreciate you taking the time. I know definitely a lot of Q&A directed your way, but I think we appreciate you giving us the time and really letting letting us share a little bit of the knowledge that you've gained over the last 24 years.
I certainly will echo the same. I really appreciate your time. Where can people find you, Jason? If anybody's interested in learning more about you, about your organization, where they can find you, we'll put those in the show notes for people to reach out.
Yeah, they can find me obviously on LinkedIn at my Jason Long. I'm the Wittmann National Sales Manager. You can find me. My email is jason.long@wittmann-group.com. You can find everything about Wittmann on our social media pages and our web page at wittmanngroup-group.com. And then go to almost any injection molding facility. You're going to see some piece of our equipment to learn a lot about it. So
that's a great. So, are you going to be at any shows in the next year or so?
So yeah, we have obviously. I have one coming up. The MAP. We've talked to Formic about the MAP group based in Indianapolis. So I'll be doing their conference in October. And then the big Super Bowl for plastics, the NPE show in May of next year. That's our Super Bowl for the United States. It's the third largest trade show in the world for plastics. So we'll be down there in Orlando fully. Our whole staff will be there. So
amazing. Glad to hear. Again, I appreciate your time, Jason. Thank you so much.
Rob, thank you guys. It was a good time.